Hello everybody, welcome to Marketing Analytics course. This is week 3 session 4 and I will be discussing about segmentation, targeting and positioning. This is Dr. Shagata Chatterjee from VGSOM IIT Kharagpur who will be taking this course for you. So, till the last presentation we have discussed about how to do segmentation, targeting, positioning using clustering methods. So, here we will actually work on a particular problem. So, if you have seen the in your files, there is a customer.csv dataset and the dataset looks like this. So, the dataset has serial number, age of a customer, male or female, male means 1 means male and 0 means female, it is a dummy variable. The income of the customers, the distance of the retail store, so it is a retail data let us say, and the distance of the retail store from the address. So, how do I know the address of the customer? I actually come to know about the address of the customer when they fills it up. So, this customer data has been tracked through the loyalty card they have. So, whenever you actually buy something to gain points, you swipe your loyalty card, and when you swipe your loyalty card, I come to know about your data. So, while you actually registered for that loyalty card, what we had was your address, and I know that the zip code of your address, or not the zip code, sometimes we know the Google location of the address as well, at least the lane's location, and from my retail store I can find out using Google Maps certain distance. So, this is the part which will be done by a coder, and this is not something that you probably have to do. You might have certain business analysts and etc. If you are doing for academic purposes, sometimes you have to do it on your own, but some other expert can do it using Google Map. So, that is number 1, distance. And then I have certain behavioral data. So, column B, C, D, E are all demographic data of the persons, and I will not use that for my segmentation. I will focus on the behavior of the people. So, F column is shopping experience, G column is NOV, that means number of visits, not shopping experience, sorry, shopping expenditure. F column was shopping expenditure in lakhs or in thousands per month. NOV was number of visits in units, and then P grow is actually how many what percentage of your purchase is in grocery, what percentage of your purchase is in food and beverage F&B, what percentage is in FMCG, and what percentage is in apparel. And there can be another various kinds of observations that you can find out, behaviors you can find out, but I am focusing on these 6. So, based on these 6 we will do our cluster analysis, and then we try to find out what kind of customers they are. So, the first thing that I will do is I will set working directory to source file location. So, w3 s3.r or actually s4, it should be s4.r, that is the file that we are working on, and your global environment should be empty, your console should be empty. In that position we are calling this particular data. So, I am calling this data has 537 observations of 11 variables, and the structure of the data looks like this, that all of the below ones are integer variables. So, they are numeric. So, I do not have any issue, I do not have to change anything. So, then I create a subset of the data, because I will work on the last 6 columns. I create the subset of the data, and I create a data which is 537 observations of 6 variables, which are basically the behavioral variables. And then the first thing that I do is I create a hierarchical cluster. So, to do that I create a distance matrix. So, the function is dist, dist, and what is the input? Input is data, and what is the method? Method is Euclidean. So, it will create a distance matrix for every person to every person, 537 to 537, it will create a distance matrix, and that is what has been created here. So, D is equal to dist, and then if I run this, I get a D which is a large distance matrix. Using this matrix, which you can print here, but 537 to 537 is very huge, there is no point on printing. If you want to save it, you can save it by write.csv and change this G to data frame and then save it. But I do not want to do that. I create a hierarchical clustering. The formula is simple. H classed is the code, H classed and then the input is D, and the method I am asking is use words method. You can use some other method as well. So, if you just search for HCLUST, here they will say that okay, method is equal to complete or method is equal to single or method is equal to average. Which one will you want? You can choose any one of these things you can choose. So, I am saying that let us say method is equal to, instead of complete or whatever, I want method is equal to let us say centroid, or let us say complete only, complete, method is equal to complete. So, complete means it will find out every distance. So, if I just run that, I got this, and then if I want to plot it, it gives me a plot and I want to show that. So, the below ones is a dendrogram. Study the dendrogram carefully. So, all these small things, I have 537 observations and they have come together, that is why it is so clumsy, but all of these things are, each of these lines at the bottom is one single person, and then they join two persons in one group, and when they join these two persons in one group, they actually achieve some distance. So, either you can start looking from the top and from the bottom. So, at the bottom, when everybody is in one segment, you will see that these segments are so close to each other that you can't even think that they are very different from each other. So, this does not make any sense to you. So, why does it make sense? So, you will carefully see that these are the guys, who are in one segment, and all these guys are in another segment. So, there are two trees that is coming up at the top. One is this people and another is this set of people. So, that means this small group are very different from the other group. Now, remember this is the data that has been created for to have this kind of a data set. Now, then out of this huge group, the next jump comes here, that these people are very different from this set of people. So, there are, I can see three segments, one is this, another is probably from here to here, this segment, and then a small segment at the back. So, there are three segments that I can see which is properly visible. So, when there are three segments which are there, we can actually run for the rest of the thing. So, what we can do? So, I will say that cut the 3 in 3 segments. So, I will say groups cut 3 into 3 run and then border them and you will get the borders properly. So, here there is one more segment that is coming up here very strictly, and I will talk about that segment probably. So, if I just clear this up and break it into 4 segments instead of 3 segments, if I run it into 4 segments, then I probably will have a better view. So, I plot this once more and then I break it into 4 segments, and now carefully see that each segment has some meaning. This is one segment, this is segment number 2 which is a big one, and segment 3 and segment 4 are very small, but they have some meaning, that is why they are coming up like that segments, and we will discuss about that. The next step is k-mean. So, to k-mean I told you that you have to decide how many segments do you want. So, one thing is I told that okay, you can have 4 segments using this. Other thing I will actually run that. So, what I am doing? I am writing. So, when there is no model, when there is absolutely no clusters, everybody is in the same thing, then what is the net, I would say, what is the segment I would say. So, if you remember the formula was like this. The formula of each, when everybody were in different segments, the formula was like this, that. So, what I will do? I will say that x person, so ith persons jth x value. So, let us say ith person is, let us say x11, x12 up to x1k. Okay. So, ith person's jth characteristics, ith person's jth characteristics minus the mean of jth characteristics, square them up, that is what? That is the mean of the distance of ith person from the mean, and then sum that up. So, what will I do? Once more, carefully see what I am writing. So, let us say there are first person whose observations are x11, x21, x31, xk1. Okay. The second person, which is x12, x12, x22, x32, xk2. Then there will be n number of persons, which is x1n, x2n, x3n, xkn, and there will be in between a jth person, ith person, who is x1i, x2i, x3i up to xki. So, total number of people is n, and when I denote any one person, I denote it with I. Now, if I take a mean, what is the mean observation? The mean observation is actually the mean of this, then the mean of this, then the mean of this. So, each one will have one mean x1 dash, x2 dash, x3 dash and xk dash. Everyone will have every parameter. So, this is brand awareness, this is price sensitivity, this is brand loyalty, this is something else. Everything will have a mean. I tried when they are all in different segments. So, sorry, probably when they are all in one segment, or in that case how much is the error when I cannot explain anything of the model. So, I will find out how 1 is distance from this, how 2 is distance from this, how 3 is distance from this, and so on. So, I will find out all of that thing. So, what is that? So, how 1 is distant from this mean, that is x11 minus x1 dash square plus x21 minus x2 dash square plus x31 minus x3 dash square and plus so on. This is the distance of guy number 1 with the mean. So, what is the distance of ith person with the mean? x1i, x2i, x3i and so on. So, can I write it like this, that x m I minus x dash m square summation m varies from 1 to k. I can write that. So, I can write this part, carefully see, I can write. So, I will just rub this off, so that we can understand it properly. So, this is the part that I am focusing on. So, I can write the equation that has been written below this equation as this. I can write it like this. So, that is what I am writing, and that is the distance. And then, so that is why what I am doing here in this code, is I am writing apply data to VAR. What does this do? Apply data to VAR. If I just run this much, it will actually give the variance of each of the column one at a time. Each of the columns, the whole data set's variance. Now, what is variance? Variance of a single column can be written like this. Just check. Variance of a single column can be written like this. Variance of a single column, can it not be written like this? So, if it is mth column, then corresponding this thing is individual observations minus the mean of that particular guy, summation of that by n minus 1, number of observations minus 1, that is variance. The root over of this is standard deviation. So, if that is variance, then can I not write that this one is nothing but n minus 1 into variance of my mth column? If I can write that properly, then you see that this is what I am writing. So, apply data to variance. So, these are the variances, then multiply with n row of data. N row of data means 537 minus 1. So, multiply with it n minus 1 and then add them up, sum it up. So, this is the distance, the within sum of squares when there is no clusters. So, when there is only one segment, not more than one segment. Now, when there are more than one segments, I will actually find out the within sum of square using a function called k-means. And I will vary from 2 to 15 means I am varying the number of clusters from 2 to 15. So, when cluster number is 2, let us say when cluster number is 2, what does k-mean will give? K-mean will say that this is k-means. What does k-means do? K-means will say, okay, centers is equal to 2. That means, it will read the data and create segments with 2 segments. Now, I do not need the segments right now, because I do not know how many segments I have, but I want to know when there are 2 segments, what is the within SS, within sum of squares. So, if I break the data set into 2 segments and for each segment I find out the sum of square, how much sum of square total I get, and that value is when centers is equal to 2. Okay, so sum of that, sorry. So, okay, so withinness I have not written correctly, withinness WITH. So, this is the 2 sum of squares of 2 segments. If there are 3, then each of the guy will have 3 different sum of squares. Sum of squares means the distance between each of the observations from the centroid of that particular segment, from the mean of that particular segment. So, I find out the distance. So, these are the 3 distance when there are 3 segments. When there are 4 segments, these are the distance, and then add them up. I join them and add them up, that is why a sum sign. So, then I put those summation. So, summation of these 2 and say that when segment is 2, this much will be the total withinness. When within SS, that means within sum of squares. When there is 3 segments, if I add these 3 guys, this one will be the total within sum of squares. If I add these 4 guys up, this one will be the total within sum of square. I save that in this WSS thing. So, if I run this, I get a WSS which is nothing but basically 15 observations. This is the observation when there was only one segment. This is the observation which is there are 2 segments, which is nothing but summation of these 2. This is when there is 3 segments. So, see, slowly the within sum of square is going down. When there is one segment, you put bananas and oranges and apples, everybody in one group. That is why the distance between the group mean from the group mean, individual guys distance is very high. Now, when you have 2 groups, the bananas come in one group and apples and oranges comes in the second group. But because bananas are there in one group, the distance of individual bananas with the group mean of banana is 0 or very low. So, that is why the distance goes down. Though oranges and apples are still, which were in the same segment, they are still different, but the overall distance has come down. Now, when you further break, you break apples and oranges also into 2 different groups, the within sum of squares further comes down. So, slowly it comes down, if you see. Now, I plot it and I want to see that how that plot comes down. So, here there is a jump, but I can say that okay, up to 4 or 5 I will take as a 4 or 3 it's a call, you can take the number of segments. So, let us say k1 is equal to 4 I decided. So, using this method I decided that k1 I will take as 4. Now, if the number of k1 means the number of segments I will take as 4. So, then what will be the observations? I will just run this line which will break the data set into 4 clusters, and if I want to see how these clusters are, I am done, I have already done the work. Now, I am doing the third part. If you remember, the third part is creating the segments parameters, the identification of the segment. The identification of the segment will look like this. So, I have done the aggregation. So, I will just plot it once more. The aggregate is like this. Check it carefully. That serial number 1. So, the serial number does not make any meaning. Segment 1, in terms of behavior, if I try to only focus on behavior and nothing else, and I will probably run once more. Oops, sorry. Yeah, so if I want to plot that once more, in terms of the behavior, you will see that segment 1 has 49,000 per month shopping experience, shopping expenditure. So, their expenditure is 49,000 per month in one retail store. On the other hand, other guys are 6,000, 6,000 or 6.6, 6.8 and 10. So, I can say 6.5 and then 7 and 11, something like that is the shopping expenditure. So, group 1 is high expenditure guys, that is number 1. But group Y visits very low amount of time, only twice in a month, and this guy's average is 5, almost 5. So, group 1 is totally different from other guys. They visit for limited number of times, 2 times a month, and purchase a lot. Their major purchase is grocery and apparel also. Grocery and apparel is their major purchase. FMCG and food and beverage is not something that they purchase a lot. What is the distance? The distance is not very different from each other. Distance for all the groups are same. This guy's income is a little bit higher than the other group. They are predominantly male, 0.875 is male, and middle aged. These guys are further younger, 33, 32 and 36. This guy is 45. So, middle aged men. So, middle aged men. So, if they are middle aged men, who are these persons? Can you imagine? So, there is a middle aged man comes twice in your shop, only twice, not more than that, probably very low amount of time they come, but they purchase in bulk 49,000 average shopping expenditure means, or probably total shopping expenditure, that means 25,000 in one shopping expenditure means they purchase in bulk. And what do they buy? They buy grocery and apparel items. Probably there. So, you do not buy 25,000 worth grocery or 25% worth apparel every month. So, a normal customer cannot buy, and if that is not the case, then probably these guys are B2B customers. That means they are small retail stores, they come and buy from this big retail store and sell it in the small retail store. They can be resellers, they can be small kirana stores or something like that. So, that is what a segment which is coming up, which is very prominent. What are the other segments? The other 3 segments are their shopping expenditure is 6, 6 and 10. So, they are not B2B, they are B2C. Now, all of them visits around 5 times. So, they are weekly visitors. So, that is okay, they are not very different about that. But segment 2 if you carefully see, or probably segment 4 if you carefully see, the FMCG is 40% of their purchase, which is majorly they come to buy FMCG. So, who are these people? They are 50-50 male female, more female than more male than female, and their age is a little bit higher than the other group, and their income is also a little bit higher than the other group. So, these guys who are a little bit higher income will focus more on FMCG, and they are ready to come from a long distance also. So, they are coming 4.25 kilometers away from there also. On the other hand, there is another group whose Major purchase is apparel, you will see 35, and these guys are youngest, 32, and they are also more or less more female are there than the other groups, and then their distance is the shortest, 3.78. So, see, the closest guys are obviously the B2B guys, and then these guys who come to buy apparel, they also want to have a lower distance. And then group 2 majorly buys FMCG, 36% also. So, okay, so we have to check now that how group 2 and group 4 are different. Group 2 also buys 36% FMCG, group 4 also buys 40% FMCG. Group 2 also makes 5 visits, group 4 also makes around 5 visits. Group 2 shopping expenditure is 6, but this guy's shopping expenditure is 11. So, there is some difference in terms of shopping expenditure. And what does that come from? That come from probably from income. This guy's income is 5.8, it is 7. So, 1 lakh extra income, that should not impact the shopping expenditure so much. There is any other difference? Okay. These guys actually make expenditure on food and beverage also. These guys have very low expenditure on food and beverage, only 12% versus 22%. So, thus group 2 I can say that group 2 are mainly male who are of age, average age of 33, and their income is around 6 lakhs per annum. They live close by within 3 kilometer or 4 kilometer distance from the retail store, and their average shopping expenditure is around 6,500 per visit or per month, and majorly they buy both F&B, that means food and beverage, and FMCG. FMCG is the primary, but they also buy significant amount of food and beverage material. On the other hand, group 4 have all of these things similar, but their shopping expenditure is around 10,000, their income is around 7 lakhs, and they only focus on FMCG, they do not focus on the rest of the thing. Probably they focus on groceries also, FMCG and groceries. So, one group probably focus on food and beverage which is packaged, another group grocery means their food and beverage which is not packaged, which is so the focus is different. The age is also a little bit higher for group 4. So, I can probably assume that these guys an age, income is higher, distance they are coming from a little bit longer distance. So, I can imagine that this fourth group is a family person, while the third group is not a family person, or if fourth group might have a larger family, might have a car because he is coming larger distance and etc. So, these are giving my some idea about what the segment is from the demographics and from the experience. And now, at the last stage, what I will do, I have to create a targeting mechanism. I have to find out that if a new customer comes up and registers with me, how will I know whether he is in segment 1 or segment 2 or segment 3 or segment 4. So, what I do is, I put another data set where I create my data 1, where I actually have put the cluster numbers, the who are in which guy is in which cluster, I have did that. So, if I just write my data $1 fit cluster and then find out a table of that divided by 537 into 100, in percentage term I know in segment 1 has only 3% people. So, though they are very prominent, they are in numbers they are very small, makes sense because B2B buyers will be small. How many kirana stores will be there in a locality? 20, 50, but there will be probably 10,000 customers and 50 retail stores. So, B2B purchases will be less, so that is why 3%, and the other one is 30%, 25%, 40%. So, they are fairly well sized. Now, I have in my data, if you remember, I have this as my positions of the persons and this as my age, male, income, distance. These are the 4 demographic variables that I have. So, using these demographic variables, I will try to predict whether he is. Now, 1, 2, 3, 4, there are 4 categories there, and this is not a linear regression because all these 4 categories are different. So, I change them to factor variable as factor, and then I run a multinomial logistic regression. So, for that I will require a library called nnet, and then I will call this model. So, I will run multinorm instead of lm I have written multinorm, that is the only difference. Then fit dot cluster is my y variable, age, male, income and distance is my x variable, and data is equal to my data 1. And if I just run this one, and if I just see the summary of the model, I get this thing. So, in the summary of the model, what it gives me? It takes 1 as the observation 1 as the base point. So, observation 1 is 0, observation 2 is the intercept is 15. For each age increases, so when age increases from 0 to 1 or for unit age increase, the chances that you will be in group 2 is least, or probably not, group 3 is least. So, age increases, your chances of being in group 1 increases, and if you are a male, then also the chances of in group 2, 3 and 4 decreases, the highest chances in group A. So, these are all negative. Income, if your income increases, your chances of being in group 2, 3, 4 is also lower, and probably lowest is in 3, and probably in comparison to that 4 is much better. And as distance increases, the chances of being in group 4 is highest. And these are the corresponding standard errors. So, how do we find out whether they are significant or not? We do the coefficient by the standard error, that will give us the t statistic or z statistics. So, we find out that z values. So, z values are for all of them, probably this one is marginal, and this guy's distance is not significant. The z value is 0.84, 0.7, 1.08. So, remember it has to be higher than the mod value of the z should be higher than 1.96. So, for distance are not significant then, but the others are significant, probably this one is also not significant. We can find out the probability, exact probability values, and the p scores. Okay, so, other than distance, which are all higher than 0.05, the rest of the 4 things, intercept, age, male and income, for all the observations they are significant. So, that means that I can probably run this thing, using not using distance, and then run, and this is the right score. So, how to interpret it? If somebody comes as an age of, if somebody comes with this observation, let us say, if somebody comes with the observation of, let us say his age is of 30 years and he is a male and his income is of 6 lakhs, then what is the observation? The probability that he will be in group 2, first of all it is the u or whatever, I do not know. So, let us say A of group 2 is basically 16.37 minus 16.37 minus 0.24 into 30 minus 1.7 into male minus 0.45 minus 1.7 into male because 1 minus 0.45 into 6. So, this is the probability that he will be in A1, A2. So, not probability, this is the measurement. And similarly, I find out A3, A4 also, what is the values, and A1 is equal to 0. So, probability that this guy will be in group 2 is basically e to the power A2 by divided by e to the power ai's, where I varies from 1 to 4. In other words, e to the power A2 by 1 by e to the power A1 is e to the power 0, that means 1, plus e to the power A2 plus e to the power A3 plus e to the power A4. So, something like that will actually give me the probability that this guy will be in group 2, and group 3 and group 4, and whichever segments probability is higher, I will put that person in that particular segment. Similar thing we can do with LDA also, and I will not do that. We can also break the model and see that how is the predictive model. So, I have broken the data set in training and testing, created the model with the training data, predict it with the testing data, and finding out the confusion matrix. It is a similar job that we have done for logistic regression. You can try out that, and here if I run these 4 lines together, this is the confusion matrix gets created. You can see that there are lots of off diagonal elements. The overall accuracy is basically 50 plus 353 and another 17. So, around 70. So, 53 plus 17, 70 out of how many? Out of 150 or what? Just 1 minute. So, training data is after 150. So, 70 out of 150 is less than 50%, which is bad. So, you have to find out some other demographic variables which explains the data set better, and you have to try to improve your predictive modeling. So, once you better predict the segmentation, which segment they will fall, the targeting becomes much easier. So, that is what we will have done about logistic regression, multi-domain logistic regression. We can discuss more about LDA in the next class with a small example on this data set itself. I will share 2-3 lines of code and we will discuss that, and we will go ahead with the next module from the next videos. Thank you very much for being with me. We will meet you in the next video once more. Thank you.